Okay, sir. I welcome all. Myself, Suri Chakravarti, Deputy Director Technical from Institution of Engineers Headquarters. So we have gone live in this webinar, and now I request our Honorary Secretary, Kotegolam Local Center, to take over the floor. Please,
Sir, shall we wait for participant or shall we start?
participants are already there.
Okay.
There are
Okay.
33 participants already joined,
Okay, sir. Okay.
so we can start.
Okay. Okay. Thank you. Good morning to all of you. Today we are going to give the webinar presentation on the 5G and IoT technologies application in coal mines. Our first panelist is ERB Brahma Reddy sir. He is ex-chairman of Telangana State Center. He served as a Indian Air Force for one and a half decade in radar system and missile. He was a member of IIF technical team to Radar Innovation Center. He served as a director technical support in Digital India at New Delhi. He headed the Institute of Engineers as a secretary and director general. He also served in various capacities in banking and finance sectors for 2 decades. Today, Sari is going to deliver a lecture on introduction of 5G and IoTs used in the coal mine industries. I welcome here Brahma Reddy sir to present your insight about the workshop webinar.
Thank you, Andy Srikanth Garu, for nice and very brief introduction. I'm really happy. Thank you very much. Now, today's topic is 5G and IoT technology applications in coal mines. Of course, how 5G plays a role in coal mines. But I think mostly, as I came to know from you, that the students are attending. So nobody is expert in that. And let me first of all come starting with from the founding basic of the 5G technology and what it is, how it works, and then in the final conclusion we can move to the what are its uses and applications in coal mines and other different industries. So now I'm sharing my this thing. Is it come? Hello? Hello?
Yes, sir, it is coming, sir. It is coming. Hello, sir, it is coming.
Yeah. Yeah, 5G and IoT technology applications in coal mines. One-day seminar is being organized by uh, Kottagudem Local Center. And I thank the chairman, the Honorary Secretary, and the headquarters, our Deputy Director Sudeepji, and all other whom I am not able to see the names and thank them giving an opportunity to participate in this local centers program. And I wish them to do more and more programs like this, not only webinar in physical also, for which definitely our state center also will give support. Yeah, today's our topic is first of all, let me tell you what is 5G. Actually, everybody is saying 5G, 5G, 5G. Whether really 5G has come to India and what are its advantages and how we were operating up to now in 3G and 4G. And in fact, in India, the 4G has been recently only taken by BSNL. Earlier, BSNL was in 3G and all the private operators or mobile operators are in 4G. Now, private mobile operators have taken over the 5G, especially Jio and Airtel and Vodafone in India. And now BSL is operating 4G. That means we are yet to spread our 5G across the country. Though it is launched in 2022, But the actual 5G means is just to say the fifth generation, but it is not unlike a technology like 4G. It's a group of networks put together under one umbrella to get different functions and different applications. So there is no uniform network for that. Where whatever application you want, you add those networks and make a one other to get the more output of those networks. And what was the now gain of this 5G is earlier when 4G was there, the speed was only around you can say the data of around mbps, maybe less than 10 mbps is to be transferred. It takes more than a minute or 2 3 minutes, but whereas now it has in the 5G, the time taken for anything uplink or downlink, all these things will be known as a time latency is 1 millisecond, and it's in gigabytes. The data transfer rate will be gigabyte. That means from mega to giga is 1,000 times faster than that. And what is the need for 5G? And what are the factors that are actually is force the in India also to take a 5G network? Because now as the applications are increasing, more number of devices, IoT devices are to be connected, and IoT requires to handle several billions of network devices connecting to one single network at the same time for energy efficient. And also 3D video, ultra high definition video streaming applications, they need a bigger bandwidth additional. And also virtual reality and reality enabled gaming and video streaming and industrial applications that requires latency time in milliseconds. And other need is the operators who are actually operating are always having a demand for faster data traffic and the quantity, more quantity of this thing, and at the same time they have to reduce the operational expenses. That is also one of the factor and the need for a 5G in India, because 4G in India is the most successful network. And also new revenue opportunities by again it is known as a disruptive. That means whatever the technology is there entirely, it is replacing the with the new infrastructure and new applications and new challenges and new benefits. So for supporting those new application, new the thing, you have the business and revenue opportunities are arising out of the wireless service providers. That is also one of the factor. And also to address the technology needs of some of the emerging use cases, like now, which were not earlier supported by 4G, like what we are calling as smart cities, smart home, like vehicles, autonomous vehicles, all those things they need for the higher time for the lowest. So you can see what is the features of a 5G in a small triangle. Actually, it is having three use cases. One is enhanced mobile broadband, another is massive mission type communication, and ultra reliable low latency communication. In this, if you see, the mobility is 500 kilometers is the total it can have for 1 hour of high mobility. Similarly, gigabytes. Now today is a 10 gigabytes. They're expecting to be 20 gigabytes. That is the peak data rate transmission data from one point to the other point, which is multi gigahertz. And also the network is highly reliable, 99.99%. And the battery life for your user equipment is also very 10 years plus. And also 1 million devices for square kilometer can be connected IoT devices. And 1 millisecond is the target for this ultra low latency. Though at present it is still we in India we are not able to reach 1 millisecond. It is I think 19 milliseconds is the highest by the Geo, and 23 milliseconds reached by the Airtel. So, and what are its features? To deliver 1,000 times higher mobile data volume per area. That's what we said. from Mbps to it has gone to giga bytes per second. So that is and 100 times number of suppose earlier for example X number of devices are possible to be connected in 4G. Now it 100 X times it is 100 times more number can be connected. And it is also using higher use data rate, and also it is life is 10 times longer than the what it was doing, and also it reduces the time taken from one network to the other network, whatever is the application we are using. And multiple standard bodies, actually 3GPP, that is the one third generation proprietary project, that is the one which developed the 5G related all standards and protocols under the direction of ITU, International Telecom Union. And also GSM is also another one more standard, and then ITU and IEEE, and also Telecom Management Forum, that is in actually UK. All these are the standards. They are the all the mobile operators they have to follow for the infrastructure as well as the their user equipment. And 5GPP, triple P, that is the 5G Infra Public Private Partnership, which drives the 5G related prototypes, standards, and solution, is also found by the ITU under its direction. Any country or any whoever is making manufacturing the 5G related equipment, this is the organization takes step. And IEEE enables the development of new innovative any use cases or any other new standards for 5G. The role of the IG, then European Telecom Standard Unit, and also IETF, that is Internet Engineering Task Force. That also is one of the standard body for evaluation of this, especially internet architecture and operation of the internet, includes the 5G networks. And then how it is 5G evolved. From this diagram, we can notice that in the 1G started in 1980s, just as analog voice, just like a landline, you are able to speak only one to one, human to human. And when the second generation started in 1990, it started with the digital voice, low speed data. Also, we are able to small text could be sent. And when third generation started in 2000, after 10 years of the to this operation, the data was the high-speed data could be sent, and there was a possible made a possibility for internet access, and a small MMS and multi message servicing was possible. And after that, in 2010, the new generation technology, that is 4G technology, which is very faster than the earlier one, and also better than third generation, and it is internet protocol based network, and a very high speed internet, and also streaming has become possible. That is how we have been watching the cricket matches and other things right from the 2010 onwards. And now 2020 onward, actually 2019 5G was launched, but and it has come into the commercial market, but 2020 onwards it has become the total almost many countries have started adopting it, and now India is no exception. Already India also has taken 5G technology launched in 2022 October, and it has got connecting more number of already told you million of devices are going to be connected for a 1 kilometer area, and also sensors and systems all put together, and it is and also increases the business opportunity and very useful for the all industries, and that is how this is 5G. We are coming to fifth generation. And what are the major technologies used in the 5G? Actually, I'll come back in the next spectrum. The spectrum is earlier we were using up to 6 gigahertz only, 700 megacycles to 6 gigacycles only, the band we were operating for all the third and fourth generation. But what is the highlight of 5G is there is a millimeter wave. That millimeter wave actually starts from 24 gigahertz onwards. And in fact, in the range of frequencies, 30 gigahertz to 300 gigahertz. And in contrast, 4G was only operating in two bands, low band and mid band, that is less than 1 gigahertz and 1 gigahertz to 6 gigahertz. And the advantage of this millimeter wave band is it is very less used, hence it is available, uh, uh, freely available from the ITU, and carries much more data than the lower frequency wave, because but the only disadvantage is bandwidth is very less, higher number of base stations it requires for doing it. And also another technology used along with in this 5G communication or 5G networking technology is 5G new radio. Is a global standard actually. Actually the 5G new radio has been invented and manufactured by the Samsung. And 5G NR, it uses two frequency, that is sub 6 means less than 6 gigahertz frequency bands, and frequency bands and through milliwave, that is 24 to 100 gigahertz. Another technology is small cell stations. Now you must have seen there is a big tower, one tower is there, and big white like tubelight type things are connected, and these are nothing, that is the antennas and other things, which is known as the tower is having a base station, and from that it is emits the radio frequency or whatever is user to this thing, and from that to use to catch the signal and talk. That means the one tower is connected to thousands of users, and you share the signal of whatever it is propagated, and then you can this your user equipment or whichever your mobile in your hand will convert those waves into sound waves and for your purpose. And we always say a signal is down, this is down. You go away from the tower, signal will very, very poor, and our signal will be losing, and you won't be able to hear properly. Because it is a 360 degrees, this thing, whether use it or not, the energy goes waste. In case of 4G, that is the omnidirectional. And now the 5G major is small cells are used so that the bandwidth is increased, which is actually because of millimeter wave, this thing is less. So that is one advantage. And also, like earlier in 4G, now you are directly connected to the uh, tower, that is base station. The actually small cell is nothing, a small base station and a big tower. Thousands of small cells are connected, and they are again further subdivided into pico, micro, and smells. And there again the range then range is just 50 meters to and so on up to 500 meters, and depending upon the application and the place and the number of users you are going to have, for that they use this category of small cells. And otherwise generalized small cell, which is only 500 meters is the its range. And also the technique used by the antennas is beamforming. That means it's totally directional. It's once it's emits. When you talk to through your the equipment, your focus of the beam will be to your user, and user will be received. And like unlike earlier, what happened? There was a SISO, single input, single output, and multi input, multi output in 4G. Up to 4G, it was only single input, single output. But in 4G, they were using both single input, single output, and MIMO, that is multi input and multi output. But when it comes to beamforming, it becomes massive multi input, multi output antenna. That means where you are using a in 4G mobile, you are having only four antennas. You need two antennas for transmission, two antennas for reception. Whereas when it has come to 5G, this becomes minimum 16 antennas to up to 250 plus, see, 56 it can be used, and depending upon the functions and the number of application the user wanted. So that is how this you are when you are talking about this beam forming, and the beam is such a way it is given from the base station directly come to the user, that is the user mobile, and from there and when you change the area, you move other place, immediately another small cell will take over this, and that is how the beamforming is maintained there, and your connection will never lose, and is very, that is why it is said very reliable, 99.99%. And also another technology, major technology used in 5G is mobile edge computing. That is, actually, it brings cloud computing closer to the user and physically, and it has two good advantages. One is it reduces the distance, decreases the latency period, and second is by keeping just the required data near the user, also reduces the amount of data that serves to handle, which also things speeds up. And another one is the I'm talking about antenna array, that is massive multi-user MIMO. MIMO means the antenna which enables the network to have more antennas per unit. The only tower is single tower, though through the ensuring larger and faster transmission of data. That is because of this massive MIMO only it is possible to transmit from earlier mega MBPS, that is mega bytes per second. Now it has become gigabytes per second, and so on. How the spectrum, I suppose this is the spectrum, and 5G spectrum is actually the total is divided into lower band below 1 gigahertz, and mid bands 1 gigahertz to 6 gigahertz, and high bands is above 24 gigahertz, that is millimeter wave. And you may ask why, where is 6 to 24 gigahertz, where it is, where the frequency has gone. Actually, the entire world and all the, it is preserved for the military operations only. In that operation, you cannot operate even on the, actually up to 2G, 3G, 4G, the lower band and mid-band only, up lower mid-band is operated. And 4G, of course, the entire lower band, lower mid-band and mid-band is being operated. 5G operates in all these things, that is the advantage. So it covers entire area, and that is the coverage, and the speed increases. And it also, the millimeter wave spectrum, which is sending a large amount of data at very, very high speeds. And it operates, as I have explained, low, mid, and high frequency, and reduced latency that will support new applications, the leveraging the power of 5G, Internet things, and also artificial intelligence applications. And it increases the capacity and 5G network that can minimize the impact of load spikes, like those that take place, sporting events and new events. And then you see what are the network challenges. It is having a frequency band and availability of spectrum challenges. You must have heard in the newspapers last 2 years. And recently also there is another one more spectrum action by the government of India at very, very high cost. Initially it was 1.5 lakh crores, I think the spectrum was sold by the government to the Geo and others who were in the auction they have to take. And that auction, whatever the cost is, the cost will again fall on the user only. So use of these multiple small antennas and base stations and is also another deployment challenge, because you have to, earlier you have a tower and 10 kilometers range, omni and 360 degrees it is covered, but it is not like that. Now it is directional. You need to place small antennas in the sense small cells, which are also known as the base station at very, very nearby. For example, within 1 kilometer, you may have to even use the electric poles or telephone poles or anything to place these things. So that is multiple um, antennas are required for 5G purpose. So and also its network is very complex and very critical because it is not a single network; it is a group of network put under one. And for everything, the maintenance and other testing and all those things, a skilled professional labor is required for the in case of 5G network. It is also challenge and testing is also always in demand unlike other 3G, 4G, all those things. Less market for 5G enabled service as of now, and it has expenses also is more in initial cost is more in 5G network because you need to change the entire thing, the entire infrastructure, what is there, throw it and it's not feasible or technically or financially for the mobile operators to change the entire thing and overnight convert into only 5G. Though we are also having, I also purchased 5G mobile and but they say the 5G, sometimes it appears Airtel 5G, but actually it is going back to 4G. You must have noticed earlier also when we were using 4G, sometimes when mobile data is weak, in the sense the signal pattern is unable to catch because of the your location or you are moving away from the tower. So it shows E over your data or H like that. That means you are in 4G, but your mobile is signal is in 3G or something. So that's why. So similar way now also in 5G, 5G will disappear and it will be going back to 4G network because now how they are operating is a non-standard alone 5G. It is not a full-fledged infrastructure of the 5G. It is the which we said 5G new radio. The new radio module is being integrated with the already existing 4G equipment to make it a 5G network and then operate the in a 5G. So what happens after a certain time, it doesn't take the entire load of the number of users. So what happens? Why it will be distributed and it will go back to 4G or even sometimes 3G also. Because even 4G equipment was a 3G equipment which was added by evolved package core network and using that they converted into 4G at that time. And now similarly now they are doing it. And of course the pure standard alone 5G, it takes another 2 years, especially in India, to come to be replaced this 4G. And also there is security and other private concerns for the 5G deployment. And that is these are the challenges. And what are the advantages for the common people? And actually parallel multiple services. Like as you know, the location and weather while we are talking to each other can affect our earlier signal because rain is there, you are not able to hear. Suppose you there is a turning, you turn the mobile, you will not be able to pick. But in 5G, such problems will not be there. There will be minimized and totally, absolutely no problem. And also you can control your PC by handset. And student sitting in any part of the world can attend his class. And this is the utility, or this is the benefit, which is also is because this millimeter wave can penetrate in higher altitudes and underground area also. So that will help in the coal mines and other things. And later, the concluding part, I will be addressing that. Doctor can also treat the patient local in remote parts. That is, you're noticing a doctor who is sitting in London is able to do operation in Hyderabad, and that become possible. And also crime rate can be monitored and it becomes easy for investing and the investigating agencies and the government from any part of the world. That is what nowadays some digital arrest and all those jargon is coming into the market, and somebody is doing something from away from there. That is how now you must have seen even the cyber crime. If you go there, cyber crime people, they will tell you, and they are operating from different part and able to catch the culprits what they are doing, and still, but uh, the hacking is going on and other activities are going on. And it is also possible to locate and search a missing person also. And also the 5G is possible and to detect and search the especially tsunamis, earthquakes, or any natural disaster that are to come. It can detect and intimate in advance, and that will be helpful for common this one. And what are the major categories of use cases? That is, the 5G actually provides as we said, the speed, low latency, and connectivity. And that means reliable connectivity. In less time, it will download and upload. And similarly, faster the data, that is the speed. And with all this, it will enable a new generation of applications and business opportunities and services that we were not seen earlier or not available to the business community. And also massive machine to machine communication. This is what the more number of devices that IoT will now connecting billions of devices. So that is what smart city, smart home, all this is possible, connecting more number of devices together into and operate from one single point. And also it is a modern industrial process and application, especially including agriculture where drones are used by using 5G communication, and in manufacturing also. Uh, Other major categories is ultra reliable low latency. That is what is also known as mission critical, including real time control of devices, especially industrial robotics and vehicle to vehicle communications and safety systems, autonomous driving, and safer transport networks. And this is the under this the recently the industrial robotics are operating in the US, especially Elon Musk company, that only you go and to buy a car or anything to his office, only robots will come and attend you, and robots will explain you about car. They will show you everything. They will drive around and then they'll show you, and that is very useful. And this is the application or a use case, and with the 5G. And a new world where remote medical care procedures and treatment is also possible. And another is enhanced mobile broadband. And what is this is providing sufficiently and significantly faster data speeds and greater capacity, keeping the entire thing under control and connected. And new applications like fixed wireless internet access for homes, outdoor broadcast applications, without the need for broadcast vans. Earlier, they used to take broadcast vans and put all that. Now that is not the 5G. The vans are not required. They can directly do use the outdoor broadcasting applications also, and also greater connectivity for the people who are on the movement, especially very useful for military services. And this is how, just I was telling, 360-degree, the 4G, which is shown as a 360-degree, if you see those lines, as propagation is done in the 360, whereas in 5G it is shown one-to-one, the user to the tower. And this is the 5G core, of course. I'm not touching. I think what is the time for me, Srikanth Garu? And there are two main components in the entire 5G mobile network.
Another
One is
another another
another
another 5 minutes, sir.
5 minutes.
5 minutes.
Radio access network and core network. And the radio access network consists of various types of facilities, including small cells. And then we were saying masts, towers, and other dedicated, which are in building home systems that connect mobile users and wireless devices to the main core network. And small cell technology we discussed earlier, they are part of it. And the core network, this is the one actually major heart of the And we talked about MIMO, massive MIMO 5G antennas, and which are possible for the connection of large number of devices and other things. Yeah, this is how the base station looks like now, new base stations. And this is the beamforming, how the propagation is done from the small cell to the box, small cell box to the your user. This is how the loop or pattern of the radiation. And if you say that what are the benefits is one is increased connectivity, thus talking improved communication because from one to one communication is improved, and also bring other benefits to individuals and society as a whole, and enhanced experiences to enable the new and enhanced experience in areas such as virtual and augmented reality, especially the gaming and video streaming. Like suppose you're having a match in Canada, going on in Canada, and you want to watch in Hyderabad. And earlier you used to also receive 4G, but it is delayed, means maybe after 1 minute, 2 minutes. But with the 5G, instantly you can view what is going on there. The same thing is downloaded here without any delay, and you will be able to feel as if you are there in the same match you're watching at the ground itself. That is the advantage of this thing. And in future is the metaverse, and with artificial intelligence and integration of 5G, and metaverse is another word which you are doing. The metaverse is nothing, is a entire real world be shown in as a virtual world. You feel as if it is a real thing is going on, and that is how the another benefit is time collaboration, and to allow people to interconnect, collaborate in real time in virtual environment, and without delay and lag that currently we experienced. And other thing, supporting high quality content, and that is what even satellite communication, satellite transmission, like your 3D graphics, any video, audio, like movies, OTT, all these things will be very, very efficiently downloaded, and all that. That quality of the content will be very high with the use of the 5G. This one. And enabling new applications also possible, like now already started in African some countries, virtual education, virtual healthcare, virtual tourism, which was not earlier possible, and now without any limitations of the existing networks. And also expanding the metaverse, which are beyond the gaming industry. The 5G is going to be convert the metaverse to expand beyond and into the other areas, and very business opportunities, especially in entertainment and social working. And potential risks from the 5G technology. Of course, the many still some researches are going on the because as I said, you're especially when you are using the mobile nearby, the mobile with four antennas today is supposed to have 16.8 decibels per 1 kg of weight. As per if you go to your mobile, put star hash 007 and again hash, you will get what is the radiation level of your mobile. If it exceeds 16.8 decibels for the 1 kg of weight, you throw it and buy a new one, because otherwise it will harm. So to the latest challenges, especially in this thing, they are doing it because they have to use same number of antennas, means 256 antennas within the same space of the four antennas, and also maintain entire features and its parameters of the antenna, especially its gain and and other major parameters. So it is a challenge because you can't increase the size of the mobile, that is user equipment, and at the same time the entire functions are high, and you have to replace so many arrays in the small space. So for that, the Chinese are in advance. They have found some material, very composite material, using for especially liquid material, for use of antenna. Earlier, we were using some solid other materials, but now they have come with some ferrous liquid uh, material which replaces that, and then so that it contains the radiation level within this one. But say still there is a risk is one is eye and skin. The eye irritation is possible if you keep talking more and skin touching the ear or any skin. So that's why they say mobile should not be carried on body. Either it should be a small bag or something. Of course, ladies carry, but gents we still follow keeping in the heart, the pocket, and all is not advisable. And globally, it is already rolled out, and India also it is there now. They say 2 lakh already stations, base stations have been deployed by the Ericsson is given order by the government of India, and I think by 2025 they say the entire world will have this 5G this one. And as I was talking, non-standalone earlier itself and I don't want to go deep. There are so many models how the base stations are made, the infrastructure part, and what are the technologies actually can be leveraged by 5G. That is one is virtualization, that is uh, then cloud services, network slicing, that is another one part, network slicing. The bandwidth or whatever is the within this thing channel it is transmitted. Now it is when it goes to virtually into this one convert into virtual channel and virtual channel it will slicing will be possible with the 5G networks earlier, which was not there. With that, no loss of transmitted data is possible in this. And mobile, IoT, that eSIM is also come into with the 5G only, and artificial intelligence is another place where they can integrate and have more number of other business opportunities. And this is how smartphone just for only this thing. And future network trends will be there are 7 trends. One is collaborative and automated physical world and connected and intelligent machines will be Internet of Senses. Instead of things become Internet of Senses and omnipresent and non-limiting connectivity, pervasive network computing, fabric, and trustworthy infrastructure and cognitive network. And what is the economic growth of the 5G? And 5G alone is actually forecasted uh, to add 2.2 trillion to the world economy by 2025. And also 5G technology, a catalyst for the economic growth in the industry, 4.0, actually projected by economic value of 13.2 trillion by the year 2035. And India is having a good 4G connectivity, uh, which leads to the highest mobile data consumption in the world, offers a great potential for 5G technology implementation. That is how government has permitted the Ericsson and other, Geo and the Airtel to use the 4G base stations for as a non-standalone 5G and implement in India. According to Ericsson, India has the world's highest data usage for smartphone at an average of 9.8 gigabytes per minute in 2022, and it is expected to double to 18 gigabytes by 2024. And what are the leading smartphone brands? And as of now, Apple, Samsung, Oppo, and all, but Apple is the leader, and all other things. And what are the challenges is intercell interference, efficient medium control, and traffic management. Actually, when we talk about coal mine, in a coal mine, it is as the deeper and deeper it goes, up to 400 meters or 500 meters, and different depths. The number of sensors and the 5G and with the connected to the, connected, the person carrying a small cell technology base station which he can place in between when he keep on digging, and it will convert and send the message video of the message very with instantly from that point of where the miner is there to the control station, the ground, so that any difficulty is arising instantly can be come to know the by the control station, the mines, and control station will take care and advise accordingly or act accordingly to see that the problem arising can be solved. Like as I said earlier, also earthquake and tsunami, all these things also can be predicted and detected by the 5G, and very useful, especially and mining industry also it is very useful. And traffic management and mission to mission devices, that is what now of course 5G has failed in fact in autonomous cars, though they are saying it because the speed is not achieved 1 millisecond, it's only 10 milliseconds in practice, but 1 millisecond is the ideal target for the this one. And recently they have tested car in US, and that failed because it could not recognize the cyclist, and it went and hit the cyclist in a testing. So now again further research is going on and trying to with the 6G, and with the 6G is nothing is the whatever speed is 100 times faster than the 5G plus sensing of it. Sensing is also another network. Sensing networks are added to that, and then sensors will be more and more powerful with the 6G technology. When 6G comes into that entire the car, whatever the will become a reality, and autonomous cars will be definitely coming in on the roads. I think by another 4 5 years. Normally, what are the disadvantages of 5G? As obstruction can impact because as the millimeter technology can penetrate into the higher altitude and the in the caves where the miners mining, what we call it the new tunnels. The tunnels also it can penetrate. But what is the problem is if any small obstruction is there, and the signal it will break the and bandwidth will not be able to reach, and the signal is not. So you need to put more and more small cells very close by. That will be to minimize those limitations of, and also it is having a limitation of rural access also, because like now suppose rural area you want to go from here 100 kilometers, you need to put though nothing is in between is below the even plain road is there, the signal cannot travel. It is having a limitation in the millimeter wave, and hence they need to put even where it is not required, you need to put more and more base stations, and that will escalate the cost. Also, it may detract from the standards, which and always it has to be under follow with the standards. And upload speeds and the download speeds may not match. For example, the download in Delhi, maybe let us say 200, it takes 200 milliseconds. When it comes to Hyderabad, it may be 270. So place to place and region to region also, this upload and the speeds can vary. It's not standard throughout. And battery is also a problem. So let us conclude that actually this platform is very useful. And since the future intelligent sensors are coming with that sensors, and the intelligent network is possible with the 5G communication, and these 5G technology with the IoT integration, and also with artificial intelligence. And there, the mine safety of the mines is appreciable. Safety will be there, and better and better they can take care of the uh, mining activities, and without much sudden accidents or sudden developments happening, and which can cause the mining activities. That will be more and more useful, and that is going to be a greater role by 5G technology by adding to the artificial intelligence in the mining, as far as the coal mines are concerned. As of in India, only one mine is there, but in China, they are already using mine safety and other this thing. The 5G is fully exploited there. And India yet to come, as we are not having a real 5G, we are having only non-stand alone 5G. And at the same time, there are a lot of 5G advanced further. It will strengthen the especially support for low cost and low power devices such as industrial wireless sensors. And they are useful, even these sensors are and smartwatches and other IVF and together bandwidths below 5 megahertz. They will be useful as the bandwidth is below. I mean, more number of the sensors are the devices are used, but at the same time, it can penetrate the signal and even under the 400 meters below in the mine also it can catch very live this thing without any interruption and without any loss of the real thing what is going on there. And in addition, the 5G also supporting it increases the aerial vehicles as well as the non terrestrial networks, that is, those who are provided by satellites and other things, with full seamless networking with terrestrial networks. And also, over time, 5G advance could evolve to support integrated sensing and communication and ambient Internet of Things, tactile and multi-modality communication services, mobile metaverse services, and networks of service robots with ambient intelligence. All this is possible in the future coming, and also very useful in as far the industry of coal mining is concerned. And the major contributors for all this infrastructure thing in the world is Ericsson, Huawei, Qualcomm, and Dutch Telecom, and also ZTE. And Samsung also to great extent, Samsung is occupying the contribution for this equipment. Thank you very much for giving me this opportunity. Srikanth Garu,
Thank you very much,
thank you.
sir.
Thank you.
Thank you very much. As intent of this webinar is to give the more insights about the 5G technologies in the first session. And then the next session is followed by how these IoT and 5G technologies is implemented actually in the coal mines. So in the second session will be carried out by another resource person. Thank you very much, sir, Brahma Reddy sir, for giving more time to explain about the 5G network evaluations and advantage of 5G networks. And we have also given the comparisons between 4G and 5G also. And you have broadly explained what are the major technologies available in 5G, like small cell stations, mobile edge computing, etc. And you have also clearly mentioned that how the 5G network challenges are going on nowadays. As we are seeing that even though 5G is available, but it is not available in remote areas only. It is in remote areas, but it is available nowadays. It is available in the metropolitan cities, even though they are facing more challenges, network challenges. So that is due to because of network deployment and there is no skilled professional also there, and there is less market is there, and managing companies managing expenses also, it is giving very difficulty, a very difficult challenge to deploy the 5G networks in even cities only. But even nowadays we are not getting in the rural area 5G networks. So lot of challenges are there. So thank you very much, sir. You have mentioned the network challenges in a critical way, and you have also mentioned the various advantages of common people about the 5G technologies, and also given the slides presentation for risk also. As we know, the 5G technology is using high frequency, which will impact our skin tissues and eyes tissues. We also mentioned that. And I also presented how the economic growth is uh, going on with the 5G technologies. Thank you very much, sir, for giving more insights about the 5G technologies in India and as well as in out of countries. And thank you very much, sir.
Thank you very much, sir, for giving me an opportunity.
Thank you, sir. Participants, if you have any questions, you can ask. 5 minutes. Okay, sir, we are not getting any questions. If we receive any
They
questions,
can ask you in the end also, sir. After the other lecture is also, they can ask. I'm available. I will
right, sir,
listen
right.
to the next speaker also. I want to listen to him. I'm keen to
Thank you.
listen.
Thank you very much, sir.
Yadav Sahab also. So I
Yes,
will
sir.
listen. If required anything they remember, they can ask, no problem.
Yes, sir. Yes. So the next panelist in number 2 is Dr. Devendra Kumar Yadav. He is the assistant professor. So Devendra Kumar Yadav has received his PhD degree from NIT Rourkela and MTech from Veer Surendra Sai University Technology, and currently he is working at XIM University Bhubaneswar. He has published many SCI and SCI papers in reputed journals on the topic of IoTs in coal mines. Now I request Devendra Kumar Yadav to give your case study how the IoTs are implemented in coal mines. Thank you, sir.
Thank you so much, sir, for the brief introduction, and thank you, Brahma sir. It was very insightful regarding the 5G and the technology, whatever you have explained. And now I am going to, and thank you so much for the IE for giving me the Institute of Engineers for giving me the opportunity to speak on this platform. So I'm sharing my PPT, sir, and let me know if it is visible or not.
Yes, sir, you are audible. You can share your PPT.
Is it visible?
Okay, sir, carry on, sir, please.
So I'm going to explain how IoT and wireless sensor systems and your 5G will be used in the mostly I will focus on the open cast mines, and this is the real-time implementation we have done in around 2022 in the open cast mines. So my topic will be based on the IoT-based wireless sensor systems or slope monitoring in the open cast mines. So these are the outlines which I'm going to cover in this my presentation. So introduction. So why we need IoT in the mine? These IoT is required because nowadays demand is very high. Okay, demand is very high. Due to that, they have to they are digging and they are going very depth in the coal mine. So for that, there must be a regular monitoring system should be there so that we can monitor the slope. And slope is a very crucial issue. Okay, in the open cast mine. So excavation of the millers is so for mining and planning engineers it become very challenge. It become very challenging uh, to uh, to work with the sustainable slope become crucial. So the consequences if you are not monitoring the slope, the consequences will be very dangerous. It may be hazardous in the both local and global way. And this may happen, this slope failure may happen due to the man-made things or due to the steeper slope or excessive water in the slope, and it may imbalance the slope, and also the slope failure may occur due to the blasting because to extract the coal in, or any metal in the mining area, they do the blasting, and to take out that coals or the minerals, they use the heavy trucks. For that, they need to develop the benches or the roads. So due to that, due to all those things, the slope failure may cause. So for this, one continuous monitoring system should be there so that we can monitor the slope stability, and it is a very crucial issue and very time sensitive issue. Okay, we cannot monitor, we cannot avoid it, but we can take the precautions, okay, when there will be slope failure, so we can inform the miners, those who are inside the mine, so that they can take the appropriate measures, so, or they can, if it is not possible to avoid it, they can come out from those areas. So we can at least save the miners or those who are working in the mines, and also the properties, okay, those who are deployed in the mines. So in already many mines in open cast mines, they use some of the instrument to measure the slope stability. So various monitoring techniques have been are there, but those are not so autonomous, or they are, or by using that they cannot monitor 24 cross 7 the slope. Okay. So nowadays people mostly in the mines I have seen they are using the total stations, and it is they cannot monitor the continuous slope 24 cross 7 by using the total station, and also it requires huge manpower to when you are carrying, you have to carry the total station, then you have to go to the mines area, then you have to take the readings, and usually they do in the mines I've seen they do the weekly, or if it is very sensitive, if the it is more if the slope is more unstable, then they monitor it by mm, 1 day or 2 days. So it is very difficult, and also they cannot monitor 24 cross 7. They take the reading at one time and then they come on next day. So it is very crucial to develop the system, so that to develop some slope monitoring system, so that it can monitor the slope 24 cross 7. So we thought of using the IoT and wireless sensor networks to be IoT and wireless sensor network together to be deployed in the mines, and with some sensors, so that we can monitor the mines 24 cross 7. So to monitor the slope, this is I'm giving the case study. Okay, already sir has covered the 5G and IoT. What is IoT? What is 5G? So mostly here we have used the TDR sensor. Okay, that is one sensor which can monitor the slope. I will explain in the further PPT how we detect the slopes. And then we have used the in mine area I have seen, and it is practical, that it is very difficult to get the network. Even 5G nowadays it is coming, 4G it is coming. If you go to the mining area, it is very hard to get the network to talk also. Okay, forget about the video calling or using the internet. So for that, we need some of the wireless communication device, so that we can transmit the data, whatever gathering from the mining area, to the base station where they have their office. So we have to so here we have chosen the LoRa, and LoRa is one of the wireless communication device. Without internet, we can transmit the data by using LoRa up to 20 kilometers. Okay, one to one, we can directly transfer whatever sensor data we are getting from the mines to 20 kilometers with a very minimal delay. So that's why we have chosen the LoRa to cover the larger area of the mines. And since the mining environment is uncertain, so flow failure can happen within the fraction of the second. So for such scenario, you need some latency pre-processing. So here time matters a lot. So here we introduce fog computing. I will talk about the fog computing in the further PPT. What is fog computing? What is cloud computing? So in this, we have taken the TDR as a sensor, and then we have taken the LoRa. In this case study, LoRa is the wireless communication module to transmit the data from the mining area where the working or where the sensor is deployed. Okay, so by taking these, we have developed the system. So these are the some of the slope parameter, how we can say how slope is unstable. So they measure in the scale of safety factor. Okay, so safety factor is the ratio of the resistance of the force of the driving force. So safety factor, if it is greater than 1, usually it is given by the DGMS. DGMS is Director General of it control the safety feature. It take control about the safety things in the mine. So if safety factor is greater than 1, then we say yes, the slope is safer, and if it is less than 1, then typically we say it is unsafe. So we have to take the precaution measures to make it stable. So these are some of the cases where where slope failure has occurred. So these are the some of the, this is the Big Nan Conway mines, and it's where very big slope failure occurs, you can visualize. And this is the Rajmal open cast mine. In 2016 and 2017, their slope failure occurs, okay, and n number of people have died, okay. So machinery loss and other loss we can bear, but human loss, it is very difficult to retrieve that loss. So for that, these are the some of the accident I have taken the cases. Accident, this is the dump failure at the SCCL mines, okay. These are the, again, these are the monitoring setup with the conventional crack. These are the some of the instruments available to monitor the cracks, okay. So this is this project, this survey has been done by our guide, that is Professor Singham Jantu. He was one of the investigator after the slope failure. So he used to use the extensometer and crack meter to monitor the cracks after the accident happens. So these are the comparison table of the slope monitoring technique. So there are different instruments are available nowadays, but in India we have seen most of the mines they are using the total stations. Most of the mines, very few mines are there who are using the automated things. So automated total station network is there. So these are the some of the technology that these total station nowadays people are practicing from. This is the traditional way they are using. Some of the mines using the LIDAR. Okay, LIDAR is one of the, it is similar, it works on the similar principle of the radar. So it basically scan the pit and if any crack is there, you can analyze the crack, how much crack is there, and all those things. And SSR is the slope stability radar. But for this, you required very huge. For SSR to run the radar, you required some of the backup, some of the electricity. So, and it is very costly also. Okay, radar, SSR, it costs around 10 crore to 15 crores. And GPS is there. These are the some of the technology, inclinometers, piezometers, track meter, OTDR. These are the safe accelerator. These are the different technology available to monitor the slope. But in India, people mostly follow the total station, and some of the mines they are using. Some of the mines also using the SSR, but in practical scenario, I have seen they are using the SSR, but it is very difficult to decode the things. They get the data, but it is very difficult to analyze the data in SSR and also in the LIDAR, because I have seen SSR representing the MCL and somewhere in the culture area, and I have practically seen, but they are facing difficulty to analyze the data. So, so before developing the system, we have find that we need some. These are the some of the gaps we have find. So we need some of the robust and cost-effective system, because there are small players are there in the mining area, like sponge iron industry are there, or some limestone mining are there. Those are private companies. They don't afford 10 crore rupees to buy the SSR. Okay. So we have to develop some system that should be cost effective, and we can monitor 24/7 the 24/7 slope of the mine. So we have find that these are some of the gaps. So these are the objective we have taken to. So first, whenever we go, this is the TDR. Whenever we get the sensor, IoT means Internet of Things. Without the sensor, you cannot do anything. Without sensing the environment, you cannot predict anything. So to sense the environment, you need some of the sensors. So here we have chosen TDR sensor. Okay, TDR sensor is very powerful sensor, and it works on the total reflection theory. And total reflection theory is very simple. Those who belong to the computer science, electronics or electrical branches, they know what is total reflection theory. When we send anything through the wire or wirelessly, so it goes and it bombards, and some of the signal will get reflected. Okay, so it works on the same principle. So this is the formula for that total. So using this TDR, we can easily locate by this figure. You can visualize if this is the mechanism we install in TDR. One coaxial cable is used, and suppose this is one of the slope in the open cast mine. So here we drill the slope, we do the drilling in the slope around it is up to how much depth is there, you can drill up to that much of holes, and then we pour this coaxial cable inside that, and we grout that, and we are grouting that coaxial cable in that, and we have the sensor. This is the sensor, and from these cables are connected to the sensor. What sensor does, it sends the sinusoidal wave. Sinusoidal wave is sent to this coaxial cable. And when any deformation is taking place, suppose this no deformation has been taken place, so whatever we send the signal, almost same signal will reflect back in the total reflection theory. According to the total reflection theory, signal should reflect back. It may happen that the strength of the signal may decreases a bit, but the same signal will reflect back in the total reflection theory. But if some failure or some of the slope or some of the deformation occurs, so what will happen? This cable will get kink, or it will get break. If it is getting break, then at that location this spike will occur. And we can easily detect, yes, the deformation has been taken place at this position, and even we can detect the exact position of the deformation, at what distance deformation has taken place. But we cannot determine the direction of the deformation, but it is usual where the void will be. It is open cast mines, and it will be in the conical like structure. So where the void will be there, in that direction the slope failure will occur. So it is obvious there is, this distance doesn't matter in that, okay, but by using this TDR we can easily know the deformation, at what position deformation has been taken place. So but the main, this is the, you can visualize the function. This is the video what I'm saying. I'm showing. You can see in this principle it works. So whenever deformation occurs, you can see here. You can visual in the screen or in the monitor. You can see one kink is occurring or one spike is there. So we can easily detect, yes, at this location the deformation is taking place, and even you can know the intensity of the deformation, how much, what is the in mm scale, you can know, yes, this 1 mm deformation is taking place, 2 mm deformation has been happened. So as per the DGMS guidelines, it is said that if deformation is more than 6 mm, then it may happen that the slope failure may occur. So in this principle it works, TDR sensor works. So when this sensor is, we have procured from the UK, and we have imported from the UK. And then the biggest problem of this, the main objective of the main thing to calibrate this sensor, and we are getting the sensor, but we don't know what value it gives and how much it gives one numerical value, but we cannot know what this value mean for. So we have to do the calibration. Any sensor, whatever you are getting, suppose you want to monitor the environment parameter, some of the parameters, then what we do, we procure the sensor, then we calibrate the sensor with some of the existing sensors, so that we can benchmark, yes, it is giving the exact value. So same thing we have done to this TDR sensor in our laboratory. So we have developed one open cast model, and in that we have performed the shear test. Shear test means it is one type of test, so that we can know how much deformation is taking place. So so you can visualize, this is the developed, we have developed the models. Okay, so this is the model, and these are the benches. These are the different benches in the open cast mine. And we have done the hole in this, and then we inserted the coaxial cable. So this to this TDR sensor coaxial cable is attached, and this you can visualize. This is the practical implementation. This is the TDR sensor. From here you can see the coaxial cable is there, and that is poured in the inserted in this model, and then we apply the deformation. We apply the deformation manually. Here you can see these benches are movable, and here we have the space, and we can measure, okay, how much deformation we apply. Suppose, for example, I have applied 1 mm deformation according to this scale, and then and the same and the value we are recording here. Okay, we get some of the numerical value from this TDR sensor, and that we are recording for 1 mm. This is the value we usually get from the from TDR sensor. We get the value in terms of that is known as reflection coefficient. Okay, so when we give 1 mm deformation and we write the value for 1 mm deformation, this is the reflection coefficient value. And usually in the screen you will get you will get the reflection coefficient value. Then according to that reflection coefficient value, we map to the deformation. That is the deformation is 1 mm or 2 mm or 3 mm or 4 mm. So same thing we have tested over here by the manual method, and we have used the different types of coaxial cable in market, and numbers of coaxial cables are available. That is RG6, and number of coaxial cables are there. So we have tested almost around 10 or 20 coaxial cable, and we have found that one coaxial cable is there. The name is RG6. That is good, and in that coaxial cable we are getting very prompt response. Okay, so this is the observed value. You can see here we have applied the deformation, and here we are getting the reflection coefficient value. Here you can see this thing we have applied. Here we have applied the manual deformation, and deformation taken place at this location. So here we are getting the reflection coefficient value, but we don't know how much mm is there. For that we require calibration. For that we have done the calibration 1 mm. For 1 mm, we have recorded this is the value for the deformation. So in this way, we have calibrated our sensor, and then we have calibrated our sensor in the shear test machine. And these are the machines are available in the laboratory in the mining in the MIT Rourkela. So we have taken the we have made the blocks of this size. So this is the RG6 cable, RG213, and numbers of cable we have tested, and this is the setup you can see. Here, this is the machine. Here we inserted the cables, and then we applied the shear deformation, and then we recorded the value of reflection coefficient. And so this is the practical implementation we have done in the laboratory, and we have recorded the different values of the RC and the mm and the reflection coefficient in the mm. Here you can visualize in this graph. We have taken here I have shown only two cables, that is RG6 and RG213. You can see here these are the reflection coefficient value, and these are the deformation in mm. And it has been noticed that, and this RG6 is very for very small changes in mm. In mm, it gives the output, but this is RG213 is a bit it don't give so much. It is not so much responsive for the small deformation. So that's why we have chosen this RG6 cable and these are the output we have got. So as per the DGMS guidelines, it says that if the deformation is more than 6 millimeters, we have to inform to the officials of the mines that please take care of this slope, because your deformation is around 6 mm. So they take care of that, because at the blasting time, when they do the blasting, this 1 mm, 2 mm, 3 mm deformation usually they get. Okay, usually with the blasting they get this. So because if it is more than 6 mm, then we say yes, deformation is taking place. We have to take care of that slope. So that's why I have tested this up to 9 mm. We up to 9 mm, and we have recorded the maximum reflection coefficient value for RG6 is 0.332, and this is unit length. Okay, and for RG213 it is 0.0142. So that's why we have chosen this is more responsive as compared to the RG213. So we have chosen this coaxial cable, and it is very, and its cost is also very less. If you go to the market, you will get 5 rupees per meter or 6 rupees per meter. So these are some of the results. We have here is the results of the deformation of the different cables. So these are the deformation we have applied. We have applied the deformation at different location of the cable. Suppose I have the 5 meter of cable. Suppose this is the cable, and this is a 5 meter cable. I have applied the deformation at different locations that I have shown in the tabular form. So I have applied the deformation 1.5 meter, and I have recorded the value for different deformation 1 mm, 2 mm, 3 mm up to 14 mm I have recorded for the RG213, and I have plotted the graph for these things, okay, for the different locations for this, and also I have found the R square value and quadratic regression. These are some of the analysis we have done, and we have find that RG6 is the best, and it gives the very prompt response. And this is the measurement of the RG6 table, and this is the output. And same as in pub, if you want to know more about, because we are running out of time, so if you want more to read about this, so we have published this one in the in the mining, in the journal of mining, in the journal that is known as Journal of Mining Science. You can download it and read this one, okay, regarding the TDR calibration. Then second one is, now we are done with the sensor that will use the TDR sensor. Now the main problem in the mines, already I said, the communication part is very vital in the mine. So how will communicate in the mine? So it is a bit, it is in mines, we don't get network everywhere. So we have to use some of the wireless sensor technology, so that we can send our data to the base station. And from in the base station, we get the network. But usually what I have seen in the mines, I have visited at least 10 to 15 mines. Actually, I belong to the computer science, and my area is computer science, but I have almost there for 1 year in the mining to know the environment of the mining, what they are facing the problem. And one more thing I want to say, in India, if in India we have seen the interdisciplinary research is, I mean, now it is growing as per the new NEP, but it is not so much. It is not. I mean, many people are not doing the interdisciplinary research, and interdisciplinary research is very, very important, because I am a computer science engineer or electrical engineer. I can contribute in that side, but if we combine with the mining engineer, then we can know the problem up there, and then we can do something for them. So same thing we have done. I have studied for at least 1 year in the mines, what they have the problems, and then we'll come to our topic, that is coverage. Then I have tested the modules. There are different modules are available to do the wireless communication. That is Zigbee and LoRa. Zigbee and LoRa is stand for the long range communication, and RFID and Bluetooth, and numbers of technology are available. But using Bluetooth, we cannot transmit the data more than 100-meter maximum. And Wi-Fi also we can use, but we cannot also transmit the data more than 100 meters. So that's why we have chosen this Zigbee. First, we have tested the Zigbee in the opencast, and these are the testing results we have tested in our NIT Rourkela environment, and we have find that this Zigbee is communicating almost 1.2 kilometer without loss of the packet. Almost, I mean, 5 to 10% of losses. 5 to 10% loss of packet is there, and that is tolerable. But we have, but when we move to the mines, we have seen the drastic change in this. And when we move to the mines, and mines is totally different scenario, and we have tested this in the one metal mine in there near the Nagpur, that is Dungri Bujug mine. Okay, in there we have tested this one. And we have found that in the mining scenario, it is only communicating up to 800 meter, but in the normal plane, it is communicating up to 1.2 kilometers. So having difference is there in the mining environment and in the normal plane environment. So we concluded that it is very difficult to use the Zigbee. Then we have moved to the LoRa. So LoRa is one technology where by using this, you can communicate one-to-one up to 20 kilometers without internet, because already I said in mining area, it is very difficult to get the network, okay, even to talk. So you forget about the communication and internet and other things, okay. And if you move to the underground mines, then it is totally, scenario is totally different. You will not get any network or anything in the underground mines. In the underground mines, you have to develop your own wireless sensor network, so that you can at least transmit the data to the mine office. From there, in the mine office, you have the internet. From there, you can communicate. So LoRa is a typical, already I said, it is one device. From that, it is work in the communication, for the communication purpose. So you can, and here it works in a different spreading factor. What is spreading factor? Spreading factor, when you increase the spreading factor, it will increase the spreading factor. In LoRa work, it basically operate from a spreading factor 6 to spreading factor 12. So mostly it will increase the spreading factor. The coverage area will increase. Suppose, for example, suppose you want to suppose for spreading factor 1 coverage area, if it is transmitting up to 1 kilometer, it will increase the spreading factor. It will transmit 1.2 kilometer. In similar way, you can, if you increase the SF 12, it can communicate maximum up to 20 kilometers. But what happens if you increase the spreading factor? The time, the packet in the time in the air will increase, means delay will increase. So we have to take care according to your application. If it is very time sensitive application, so you should operate this one in the SF6 or SF7. And if it is not so much time sensitive application, you can go up to SF12. And also it takes care of the security also. So it uses AES 128. Already those who know, in cryptography or blockchain, they know what is AES 128. So here data encryption is also there. So I'm not going much depth in this LoRa. So we have used the LoRa in our case, and but using LoRa you cannot transmit the video. It is only meant for the data transmission or the sensor data. So this is the architecture of our system. What we do, we deploy the sensors, and from there we use the LoRa gateway, and then we are sending. Here we have the PDR sensor, and then we send to the network layer, and then from, suppose this is mine office, and from mine office I am uploading to the internet world, because in mine office we get the network, and from there we can use the services of the cloud. We can upload the data in the cloud. And why IoT is required? Because suppose one mine is there, and their CMD want to see the status of that mine. So they can easily, by using the authentic username and password, they can easily access that data. So that's why here we have used the IoT. So mainly I will move to our proposed system. So this is our developed system. This is our proposed system. So this is mines, and we have deployed the sensor in the mine. So using this PDR, we can monitor at least 2,000 locations. Using one sensor, we can monitor 2,000 locations, because it uses the multiplexer from one. It uses the multiplexer, and we can use, by using this one PDR sensor, we can monitor at least 2,000 locations in the mines. Okay. So 2,000 location is enough, okay, to monitor the working area where the work is going on. So this is the overall architecture we have designed. This is the sensor. This is the sensor module, and this is the communication module. We are using the LoRa, and then we are using gateway, and then we are using the cellular network, or Ethernet, or anything you can use, that may be 5G, 4G, or 3G, and then you can upload to the server, and then you can visualize the data. So the testing we have done the performance evaluation of this LoRa in the open in the open space, as well as in the mining environment, this is the open. I'm not going into much depth, and these are some of the results we have obtained from that, and we have found that and we have concluded that using the spreading sector, we can easily communicate up to 2 kilometers in the open space. And because in our case, we have to communicate from mines to the field office. The distance is around 1.4 kilometers. So that's why and it is very sensitive data. So we have chosen this spreading factor 6. In spreading factor 6, we are achieving the distance. But I have tested for other spreading factor also to know the range of this device, how much range it is giving. So already I said, if you want, it can easily transmit the data up to 20 kilometers. So in spreading factor 6, I have tested, and we have found that we are getting the range of 2.3 kilometers. So I will stop. I've stopped testing at SF7 I've got 2.3 and SF6 I've got the range up to 2.2 to 2.5 kilometers, and that is enough for our case, 2.05 kilometers. And we have, if you want to know more in the details, so you can go to we have published this paper in the Arabian Journal of Science and Engineering, and you can visit to this link. I will share the link with you if anybody of you are interested. So this is then we have, and already I said it is a very time sensitive application. So we have to process the data at the edge only, That's why I have used here the fog computing approach, so that I can process the data at the mine side only, and I can give the information to some of the officials, those who are present in the mine side, That's why I have used the fog computing approach, and then after compiling the data, I am sending the data to the cloud. So what is fog computing? Fog computing is one layer in between edge device and between the cloud. So it is it will take them usually to upload the data in the fog computing we require internet and other things, and for that delay will be increased. So if you are using the cloud computing, it will take more time to get the results. So that's why we move to the fog computing. In fog computing, what we do, we process the data at the edge, and we conclude the information, and same information we send to the we are broadcasting to the some of the officials, those who are like safety officer or mine manager, those who are present, and those they take care of all those things. So this is the typical architecture for our applications, for our system. So this is the fog layer architecture. So we have used one of the fog layer at the this is the sensor. From sensor we are taking the data, and by using the LoRa we are transmitting to the fog layer. Fog layer, you can imagine this is one the computational station we are having at the mine side, and from there we are computing the results, and then and there we are sharing these results to the mine official, and after that we are uploading these data to the cloud for the further analysis, and then we are sending to the end user. So we are directly sending data to the end user from the fog computing, as well as by using the cloud computing we are storing the data for the further use. In the cloud you can store the data. In fog also we can store the data, but it has a limited computational power, so we cannot store the data for a longer time. So for that, I'm sending this data to the cloud, and if you are storing in the cloud, and from there anybody can visualize from any part of the world. Okay, so that's why we are uploading the data to the cloud. So these are some of the mathematical things we have to model the system we have done. So I'm not going much deeper into these mathematical things. So the result, here I am discussing the result. So I have used suppose I want to suppose I have deployed the sensor in the very sensitive area. Those are the working area. Okay, those are the working area. Suppose one slope is there in that, and they are digging the coal or metal from that slope area. So that is known as very sensitive area, and other slopes are there that are digging is not going on. So we can categorize that one into the not much sensitive area. So those who are the sensitive area data, we have segregated the data in the sensitive and non-sensitive area. Those who are the sensitive data, we are processing that data into the fog node, and those who are not sensitive, that data we are sending to the cloud, because in that we can tolerate the latency, but in sensitive data we cannot tolerate the latency. It should be it should take very less time. In a fraction of time it should give the result. So here you can see the result. So if you are uploading the data to the cloud, all the data to the cloud, this green line represents the traditional cloud computing. If you are uploading all the data to the cloud, and there you are doing the computational things, and then it takes a lot of time. And if you are using the fog layer only, fog node only, it takes very almost very less time. Okay, it is one tenth of that one. So that's why we have segregated our our area into the sensitive area, non-sensitive area. Those are very sensitive area. We are processing the data in the fog computing, and then we are sending that data to the cloud. And those who are the non-sensitive area, that data we are directly sending to the cloud, and that will be that computation will be done in the cloud, and then that result will be shown, will be stored in the to the officials by using authentic username and password. So this paper we have published in the IEEE wireless sensor system. If you want to know much about this, then you can visualize this paper. And this is the architecture of the developed system. So already I have shown the architecture. The same architecture is there. Only we have used one fog node only because we have deployed only one sensor and we are monitoring only 4 locations. So if we increase the number of locations, then we may require more number of fog nodes. So this is the testing we have done in the practical side and all those things. And this, sir, how many times we have?
10 minutes more.
So these are some of the results. I'm not going to the depth. So these are some of the technical things. So this is the packet deflection ratio. Means whatever data we are transmitting, we are getting that data is delivered to the base station or not. So we have found that up to 2.5 kilometers, up to 2.3 kilometers, the data is almost we are receiving a 90% packet ratio rate. Means out of 100 packets we are receiving a 95 packet. So that is tolerable in this system. So this is this graph shows the sensing, and here we have done the path loss modeling and standard deviation. So this is the graph for that. And then the last one is we have developed the system and we have deployed in the mines, and whatever system I have explained, same system is deployed in the mines, and we have monitored for almost 8 months in the mines, 6 to 8 months. And we have compared our result with the whatever they are having the traditional things, like they are using the we compare our result with the total stations. So that we can benchmark our developed system. So this is the system, and same as this is the flow chart, same as we deployed in the mines. So in this mines we are monitoring the 3 locations. So this is the open cast mines. You can see this is the aerial view, or this is the view of mines, and we are communicating to the mine. This is the mine office. Here we have the receiver, and from here we are sending the data to this locations, and by using TDR we are taking the data and we are transmitting the data through the Zigbee, and the mine side we are using the internet to upload the data into the cloud. So this is the real mine location. We have installed we have installed the sensor with these 3 locations, and here we have and in this room we have kept our sensor. And in mining area, you will not get power everywhere, so we have used the battery and the solar panels to get the power. And this system runs on only 12 volt. Okay, so only 12 volts. So the same system has been deployed here. These are the results we have got. These are the results, and we have monitored at least for 6 months. For here, I have the result for 7 months. So these GUI we have developed. These are the 3 location data we are monitoring, and this has been shown, and this same data will be shown to the same data is shown to the mine officials at the fog layer. Okay, they can visualize direct data from here, and also we are having the alarm system. Means if the deformation is around 6 mm, then it will give the alarm to the mining people. Okay, in mining area they have the sirens. So whenever it reaches the 6 millimeters, then siren will give the warning that it might happen that this area slope may fail. Okay, so that one also we have incorporated in this. So this is the GUI we have developed, and we have used the Python to code and other things, and this is the result we have got. We have monitored for at least this result I have shown. This is here you can see this is a gatewise result. And we have found that in the mining, in that area, there was no, uh, uh, there is no deformation in the slope for the 6 months whatever we have monitored, and same has been and same result we have obtained from the uh, from the total station whatever they are whatever they usually practice, they usually monitor the location with the total station. So, and it has been, the developed system, whatever you have developed, and it can monitor the slope for 24/7 without any human intervention. And at least for 4 months, no need to go to the mine site to see whether instrument is good. At least for 4 5 months, without touch, this instrument, our developed system is working, and also it is got recognized by the DGMS people. Okay, so at that time I don't remember the name of some G Narayan, and he was the DG, and he has came to see and he has came physically to see this system, and he has appreciated us also. So these are the results whatever we have got from the total station. In also total station also we have seen that there is no deformation. So we have benchmarked our system, and this paper we have published in the IEEE transaction on the instrumentation and measurement. And if you want to know more about that, then you can visualize this paper. So at last, these are the conclusion. So we have found that this developed system is very useful, and we can and many and this Dongri Bujur mines nowadays also they are using this system to monitor the slope, because it is very effective and it is very cost effective also. Okay, it can cost only around 30 lakhs, maximum 30 lakhs. Okay, maximum 30 lakhs, and no need of anybody to analyze the data or do the anything. It measure the data, and it will give the result, appropriate result, which can be understandable by the miner. They can easily understand. Okay, because it gives the result in the Okay, so this is the deformation, now this is the deformation. So they can easily know the data. So this is the conclusion. So we consider that this is very useful to the mining people, and people are using in the mining area. They are monitoring the slope by using this instrument. And it is also very low, very low, very less. This is very cheaper, okay, as compared to the other instruments whatever are available in the market. It is very costly. If you go for the LIDAR, it is almost cost around 2 to 3 crores, and that is very huge cost. For that, you need one engineer to interpret the data, to analyze the data. But in our system, there is no need of external people. You will easily get the, you will easily analyze there is no need to analyze the data. You are getting the data in the So now this is the deformation, this is the deformation. But using this system also has some lacuna. By using this system, we cannot predict the local failure. From the surface we cannot predict that one, but internal failure, internal deformation, uh, we can easily know how much deformation is taking place. And by using fog computing, and using fog computing here, we are analyzing the result in the fraction of seconds. So this is one of the great achievement, and first time we have deployed this fog computing in the mining area, in cooperation of the IOT. So this is the some of the practical cases, and we have deployed in the mines, and we have tested, and we have analyzed, and these systems are used in the mines. So these are some of the references. Thank you. That's all from my side, and I would like to thank, and I think I have completed at the time. Thank you for giving me the opportunity.
Thank you, Dr. Devendra Kumar Yadav, for giving a fantastic case study about the slope failure in open cast coal mines. Thank you very much. I think nowadays it is very requirement is there in the open cast coal mines and underground coal mines to automate the mines. So it is essential to prevent the accidents. So that's why nowadays electronics is the major contributor to prevent to sense the incident before the occurrence of the incidents. So that's why nowadays electronics are emerging in the open cast and as well as underground coal mines. So thank you very much, Dr. Devendra Kumar, for giving your case study on the open cast coal mine slope failures. And you have clearly explained how what are the different parameters to fail the slopes, and you have also explained very clearly how to sense the slope failure by using different sensors, and you are also categorized the different types of sensors available in the nowadays in the market. Different categories and variations also you have shown in one slide and comparisons, and you have also clearly explained how before installing our implemented device, how to check whether our device is properly sensing the slope failures or not. So for that you have clearly shown to the audience how to model open cast coal mine in a laboratory and how to how to calibrate our sensors. You also explained very clearly, and also explained RG6 and RG213 cable comparisons very clearly, so that people can understand. They will go for the next different type of cable instead of using these two. And you also clearly elaborately explain what are the transmitting communication technologies available like Zigbee and LoRa, and we also shown the differences between Zigbee and LoRa comparisons. And finally, we explain how the fog computations will be helpful to process the data. So that is also understood by the audience. And finally, you developed the graphical user interface development to analyze the data visually to the miners and to prevent the accidents in the coal mines. Thank you very much, Dr. Devendra Kumar, for giving your case study elaborately to the audience. Thank you very much from IA Kottagudem local chapter. And I request the audience to interact with Dr. Devendra Kumar. It will be helpful for your future to understand the different problems and how to enter into the open cast coal mines. I request audience to ask the questions. Or else you can type the question also, which will be helpful for your future career.
Also, if anybody is interested, I'm working in the image processing also in the underground mine. Okay, how we can monitor the health of the mine in the underground, okay, using the lidar and cameras. So, if anybody is interested, they can contact me on my given email ID.
Yeah. Okay, thank you, sir. I request Sri Karuna Kumar sir for giving vote of thanks.
So very good evening, sir. Today is really the excellent subject experts delivered on the IoT and 5G technologies. In the particular course, first of all, thanks to the honorable immediately past chairman of the Institute of Engineers, Hyderabad Center, Sri Brahmananda Reddy Garu. He was given the fundamental things. What is the present scenario of the 5G technology and its adverse effects and utilization, and also types of the 5G technology. They elaborately given, useful to the audience to their career for the further improvement of their applications in their various fields. And also special thanks to the Dr. Devendra Kumar Yadav giving the real-time opencast monitoring system, sir. Very great input you are given, sir. It's very informative regarding the time domain reflectometers and also other your comparison is very excellent compared to the conventional system to this system. I hope that it is very, very useful for those who are research oriented, the field of slope stability, and particularly used by the IoT. Because of the mining, you are also coded restrictions of the what you call or technology in the mines, because of that is a far away. The system is completely different coal mine system, but now with the sophisticated electronic instruments, by using, you are alarming to the safety to those who are working in the man and material and production. It is very useful, sir. Special thanks to both of the studio experts, and also we are thanks to the chairman, sir, Rama Mohan Rao garu, giving our backbone. He was advised us to time latest webinars you have to conduct. He was encouraged us, and also thanks to our honorary secretary of the Institute of Engineering Kottagudem, Sri Dr. B. Srikanth sir. He was identified excellent experts, and of course, Brahmananda garu is our grand backbone of our institution. Sir, always you are supporting us, sir. It's a special thanks for once again. And also our past immediate chairman, Sri Jani Ramayara also, sir, also due to his some other personal work, is unable to attend it due to some special leave. Thanks to all the division members of our institutions, your kind cooperation and participation. And also is a wonderful thing, sir. We are attend 70 members, participants are attended this program. I think if now is a 50 plus is there in screen, most of them is elected. It is a great thing, sir. We are furthermore this type of webinars we will be conducting in future. Thank you very much. Thank you very much, sir.
Sir, Devendra, sir, there are two questions for you. One question is, sir, can we have any similar technology for underground?
Yes, we can use this TDR in the underground mines also. Okay, this is one cable. We can install that cable in the underground mine also. We have not tested TDR in the underground mines, but we can use this TDR in the underground mines. But we have find that in underground mines, the TDR, I mean, it don't work, I mean, very nicely. And we have, I'm working in the underground mine also, and we find that LIDAR is more efficient in the underground mines, because in underground mines we don't have the slopes, so we have to monitor only the roof falls, okay, sagging of the roof falls or the local failure. For that, it is very good to use the LIDAR, so that if you can monitor the surface only, you can monitor the surface.
Okay. And there is another question for Suresh Shaila. Please elaborate LoRa and challenges faced during implementation of LoRa. Is there any regulation to follow as per CMR 2017 for implementation of LoRa?
They have some of the regulation there, which we have to use the intrinsic type semiconductor, so that we can avoid catching of the fire in the mines. So these are the safety rules are there. So we have already incorporated all those things. So we have to case our LoRa in such a way that so that when some spark will be there, so that spark don't come out from that. Okay, otherwise it will catch the fire. So already it works in the 3.3 volt. So mostly don't spark. If it will blow away also, I mean, you cannot know that this has been blow away. Okay, but it still
it should be flame protection.
Yes, it should be flame protection. So we have followed all the regulation, whatever
yes,
regulation.
whatever the electronics components you use, you should be under regulations only.
Yes,
it should be in the safety precautions should be followed.
Yes.
And one interesting question for you, Devendra sir, that is Priyanjit Das. What are the challenges faced by you, sir, during integration of IoT in the mining application?
Yeah, it is a bit difficult. I said already we don't have access of the internet in the mining area. Otherwise there is no need to communicate this data to the mine office. We can directly use 5G, 4G, already 4G to communicate directly. Already I have used the LoRa. We have used the PICOM, that is one manufacturer is there. It has embedded LoRa, Wi-Fi, Bluetooth, everything in one chip, only one single chip. If this internet is available in the mining area, so we can directly transmit the data to the cloud, and we can store the data and we can analyze the data. And totally mining scenario is totally different from the normal scenario, whatever we are seeing in the, open air. Because I mean, initially also I think that yes, my device, I have tested the device in our campus, that is IIT Rourkela campus. It gives us the 5 kilometer range, 6 kilometer range. When we go to the mines, almost 50% it decreases. Okay, it gives around 2.5 kilometer already as from the result. So totally it is different. So we have to benchmark our whatever we are using. We have to benchmark all those instruments in the mining in the mining scenario, so that we can know the exact communication range what they are giving. And the problem I faced already, I explained that the only internet is not reachable, so we have to transmit the data to the mine office, and then we have to send the data to the cloud for analysis purpose.
Thank you, sir. Thank you for your patient answers. Thank you very much. Thank you, sir, Brahma Reddy, sir. Thank you, Karnakumar, sir, and Chakrabarti, sir.
Thank you, sir. Thank you very much, sir.
Thank you, sir. Okay, sir.
Thank you so much, sir. Can I leave?
You can leave, sir.
Thank you, sir.
Sir, so Chakrabarti, sir, it is
yes,
over.
sir. So I am ending the webinar here.
Hello, sir.
Yes, sir.
National anthem.
Okay, sir.
Okay, yeah.
Play always. Keep in mobile and play what is there.
Sir, Karnakumar, sir,
చెప్పండి.
నేషనల్ యాంథమ్.
ఓకే ఓకే ప్లే చేస్తారా?
అదే
ప్లే చేయండి సార్.
మీకు పంపించాను కదా.
మొబైల్ ప్లే చేయండి, ఆటోమేటిక్ వచ్చేస్తుంది కదా.
నాకు పంపించారా? భాగ్య విధాత జయ హే జయ హే జయ 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 హే.
థ్యాంక్ యూ, సార్. సార్ చక్రవర్తి సార్, హలో హలో.
Yes, sir.
సార్ కెన్ ఎగ్జిట్ సార్.